Okay, so now in the previous video, we have looked at the two independent variables only. Okay, so now we want to look at the function of three independent variables. Okay, x, y, and z. Okay, which is f is x, y, z lah. This is the notation. Okay, so we have three partial derivative in this case. Okay, f subscript x, f subscript y, and f subscript z. Okay, so if we want to find the partial derivative of fx, so meaning that we calculated it by holding y and z as a constant. Okay, so same for fy, we will hold the x and z as a constant. Okay, so if for the fz, so we will hold x and y as a constant. Okay, so now let's look at the example here. Okay, let's say we have the fxyz is equal to cos x squared plus 2xy plus y z cubed. Okay, so now we want to find the fx. Okay, so for the fx, so meaning that we will hold y and z as a constant. Okay, so now fx is, okay, so we need to differentiate. Okay, so we need to differentiate cos x squared. So for differentiate cos is negative sign, and then differentiate again the x squared, will obtain 2x. Okay, so meaning that we will have negative 2x sine x squared. Okay, plus, okay, for 2x over y, we will hold y as a constant, so meaning that we will obtain 2 over y lah. Okay, and then y z cube considered as a constant, so plus 0. Okay, so this is the only answer. Okay, so how about fy? Okay, so for fy, look at the first term. Okay, so this one cos x squared. Okay, so let's me write everything. If we differentiate cos x squared, okay, so we will obtain 0 lah. Okay, because that one is a constant. If we differentiate 2x, okay, over y. Okay, so in this case 2x is a constant, so we just we need to differentiate 1 over y. Okay, so 1 over y, so basically is same as d dy 2xy power of minus 1, isn't it? Okay, so that we need to differentiate y. Okay, so we will have, because we need to consider the 2x as a constant, so for the y, we will have minus 1 y power of minus 2. So we'll obtain negative 2, we just rearrange 2x over y squared lah. Okay, and then partial derivative for y z cube. How about this one? Oh, sorry, fy, betul lah. Okay, how about this one? Okay, so this one a little bit tricky because we have y z cube. Z cube doesn't matter because it is what we call that, constant, right? So how about we want to differentiate y. Okay, so this case it is product rule. Okay, product rule, if you remember. Okay, so product rule is we need to differentiate, okay, y remain and z cube remain, differentiate ey is ey lah, plus ey remain, z cube remain, differentiate y, will obtain 1. So this is the answer. Okay, so therefore we just add up everything. Okay, the fy is equal to negative 2xy squared plus yz cube ey plus eyz cube. Okay, so this is the answer for fy. Okay, so now let's look at the fz. Okay, so this time, okay, so become everything blue. Okay, alright, so for fz, okay, we hold the x and y as a constant, so meaning that del z, okay, cos x squared 0, del z 2x over y also 0 because it's constant, del z for y z cube. Okay, so this one we need to differentiate 3z squared, so y as a constant remain. So our answer here is 3z squared y. So this is our answer. Okay, alright, now let's move to the higher order partial derivative. Okay, so the first one, just now we have first order only. Okay, so meaning that we differentiate once. Okay, so for higher order means that we differentiate twice. Okay, so for partial derivative meaning that we differentiate partially twice. Okay, alright, so if fxy is a function with two variables, so we consider two variables, then fx and fy are also function with two variables. Okay, the partial derivative of fx and fy are the second order partial derivative of fx. Okay, and they are defined as, okay, so if the partial derivative of fx and fy are the second partial derivative, they are will define as fxx, fxy, fyx, okay, what else, fyy. Okay. Okay, so this is the second order partial derivative. This is the notation, either fss, fsy, fyx and fyy. Okay, so what is that? Okay, for fxx, meaning that we differentiate del x and del x again lah. Okay, so twice, so meaning that del squared f del x squared. Okay, for fxy meaning that we differentiate del f del x and then we differentiate it again del y. Okay, so it becomes del squared f del y del x. Okay, so for for fyx meaning that we differentiate that del f del y and then we differentiate it again del x. Okay, so it becomes del squared f del x del y. Okay, so for fyy it become del squared f del y squared. Okay, alright. Okay, remember this part here. If you obtain fxy, meaning that we differentiate x first, and then we differentiate it again y. Okay, same goes for this one, meaning that we differentiate the y first, this one, and then we differentiate it x. Okay, meaning that we differentiate the y first and then we differentiate x again, the second one. Okay, alright, example. Okay, let's say we have fxx, fxy. Okay, so we want to find fxx, fxy, fyx and fyy. Okay, so given fxy here equal to x squared exponent ty. Okay, so the first one, let's say you want to find fxx. Okay, so fxx meaning that we need to differentiate del x, del f, del x. This is the definition of del squared f, del x squared. Okay, so this is the definition. Okay, so first of course, we need to differentiate with respect to fx dulu. Okay, so y we will consider as a constant lah. So we will obtain 2x exponent 3y. Okay, after that we need to differentiate it again. Meaning that we differentiate it again, del x the 2x e 3y. Okay, so meaning that we differentiate, we will obtain 2e 3y lah. Okay, alright. Okay, so now next one, for put it here, fxy. Okay, so fxy means we differentiate del f del x first. Okay, meaning that del squared f del y del x. Okay, so first of course we need to differentiate fx. Okay, so meaning that del x. Okay, so x squared e 3y first. We will obtain in this case samalah for this one, 2x e 3y, and then we need to differentiate fxy, meaning that we differentiate it again, 2x e 3y. Okay, so we hold the x as a constant, we just differentiate e 3y, so we'll obtain 6x e 3y. Okay, alright, so next one is we want to find the f, what is the question? fyx. Okay, and then number 4 here, fyy. Okay, alright, so of course we need to differentiate fy first. Okay, so del y, okay, x squared e 3y. So we hold x as a constant. Okay, therefore we will obtain 3x squared e 3y. Okay, and then fyx is meaning that we differentiate x, the fy, okay, e 3y. So we hold x as a constant, we will obtain 6x e 3y. Okay, alright, this one here, fy. Okay, so we have the same as this. Okay, we differentiate del y, x squared e 3y. So we obtain 3x squared e 3y. Okay, so and then we differentiate it again, del y, 3x squared e 3y, which is we will obtain 9, yeah, 9x squared e 3y.